right, so we're pulling out our first cell and it needs to be rinsed off.
Beaker one. Yep.
And so we have this in a, inside the cell is water and outside is the starch. So we are going to test both places to see what we ended up having. Okay, and if you remember from previously, when we tested foods, we use iodine to test for starch. So I will attempt to carefully pull out some of the starch liquid. All right. So this should be, I'm gonna use this as my key here. All right, so inside the cell should be water, and we'll see what that comes out to be.
And that's,
This is our iodine.
okay.
Couple drops. All right, so it has turned a dark, so it looks like our starch solution has gotten into our cell. Let's see what happened here. Okay, and this one, there's still starch solution outside. It's that purplish color.
So iodine indicates starch.
Yes.
Mm-hmm.
All right.
Excellent. There you go.
Okay, so our second one that we're going to go through is there's water inside and glucose outside. I'm going to rinse this to see what we might end up with. Oh, sorry. Trying to get this open. All right, here we go. All right, so we're going to take the solution of what's inside our cell and put it in here. We'll be using Benedict's to test this. See if there's sugar in either location.
Mm-hmm. Glucose.
So, or glucose. Okay, so here's our Benedict's. Put a few drops in here. It's going to stay blue. We need to set this in our hot water bath. So I will set that in there. And let's see if we can do this so that it doesn't tip over. I'll just hold it. This takes a few moments. Doesn't look like anything's changing. All right, I'm also going to put some of our outside liquid into another beaker. And put some Benedict's in this because I'm going to test this here. color change. All right, so it looks like we are testing inside for glucose. Looks like there's glucose in there. Some yellowish green.
So the glucose went through the semi-permeable membrane.
Yeah. And it looks like our starch traveled through too. All right, so we're setting it fairly yellow there. And let's test the outside because that one's supposed to definitely have glucose in it. Turn that up a little bit. I don't know, 6 or 7. Maybe I'll speed it up a little bit. So we'll see what happens. See if some of the glucose stayed outside of the cell. It does take a little while sometimes. Maybe all the glucose left and went inside the cell.
That's what it looks like. But just some of the starch went in, not all of it.
However, it seemed like with the last beaker, as soon as I was ready to pull it out and say nothing moved, it started to turn color. So I thought maybe leave this another moment or two and we'll see what happens. Okay, so it looks like we're starting to go yellow in our environment outside of our beaker number 2. So I will leave these here as this is what happened. Okay, so we are going to be taking a look at beaker 3. Inside the cell is starch, outside the cell is water. So I'll do a quick little rinse of our cell to make sure I don't have anything on the outside when I cut into it. A couple of these. Ready to go. cut the top, and then I carefully take the insides out. And so we started with starch inside the cell, so let's see if that stayed in there. More. Okay. So put that there. Remember, we're using iodine to test for starch. Drops in there. It looks like we still have starch in our cell. Okay, where it started. And then I'm going to test the outside of the cell to see what we have, what may have happened with the starch. Okay, and this, it looks like maybe some of the starch, I'll leave it down here, some of the starch did move
Through the membrane.
through the cell, through our model there.
Mm-hmm.
All right, so I'm gonna pull our next one out and rinse that.
Beaker number 4.
Yeah. And what's interesting about this one, it appears that my cell has filled in, you know, there's more liquid in there than it originally started with.
Mm.
So kind of curious as to what our test results are gonna be. So we have glucose in this. And I'm gonna lose some of this. Get a bunch of this in there. And remember, we're testing it with Benedict solution, so our light blue solution here. Several drops in this. And then we'll stick it in our hot water bath, because that's how we get Benedict solution to work. Now we started with glucose inside the cell, so I would maybe expect to see glucose, it testing positive for that. May take us a moment or two. Like it's starting to turn a little green. So it's looking like we do have some glucose present. I'm still kind of curious as to why this one kind of puffed up is a little bit bigger than the other ones. So I would kind of wonder what happened with that. So we're actually starting to turn orange. So there's a lot of glucose left in there. Let me pull a little bit of the outside of the cell out. So we can test that. Put some more Benedicts in it. Put that in our hot water bath. See if any of the glucose passed out of our model cell. Into the environment outside. Oh, this really turned orange.
Mm-hmm.
Oh, look, we're getting our color change. So some of that glucose came out of our cell, passed through. It's looking like actually quite a bit, considering the deep color that we're getting. Looks like we might be heading towards orange. Yep. All right, so I'm gonna set that there. And actually, we're at kind of a reddish orange for inside the cell. And then, let's see if that one's cooled down enough. So that's inside the cell. This is outside the cell. All right, so in our first beaker here, our first model that we had set up, we had starch in the cell, no, water in the cell and starch outside of the cell. What happened was, it appears that the starch got into the cell. According to our study, that is not supposed to happen. And so, kind of curious as to what could have caused that. So, could it be human error? Could it have been the materials that I was using? I have to admit, they're not the newest of materials. Could it have been that starch does actually pass through a membrane? So, some things to kind of think about, maybe discuss in your small groups, and share out your thoughts with the class. Our second one here, we had water in the cell and glucose outside of the cell. And you can tell that in this one, this is our beaker that had the inside of the cell, which was just water, that we ended up with glucose. Book says that that's what's supposed to happen. The glucose molecule is supposed to be able to move back and forth. And we can see that there was some glucose left in our cell. Here we have starch inside the cell and water outside of the cell. It appears that we still have starch in our cell. However, some starch made its way out into the cell environment that just had water. And so once again, why would this have occurred? Okay, would this be, human error? Is it materials? Is it that it actually passes? So maybe that would be another good conversation to have.
Sure.
Our last beaker, we had glucose in the cell, and you can see that here. And actually, this is a pretty heavy concentration of glucose since it's orange and not the yellow we saw previously. And in the outside of that cell, the glucose did pass into that water, and you can see that it's pretty heavy glucose concentration. I also want to remind you that in the cell for this one, for beaker 4, that there seemed to be more material in that cell when I got into it. And so, wonder what else was brought into that cell, that model as it sat overnight. So another good piece of conversation there, like what could have been added to that cell.
Just an FYI to everyone, the iodine is from August of 2016, and the date on the Benedict solution is August of 2016 as well, to add a little fuel to the combustion here.